So, all right, yesterday, right? Yesterday we talked about using the equation of a line to draw a line on a graph, right? We talked about the two pieces that you need and the form for the equation. The equation was in the form of y equals mx plus c. What does m always stand for? Just call it out. Anybody? The gradient, right. Also known as the slope, right? Okay. And it's always, even if it's a whole number, it always needs to be read as a fraction when you're using it. But if you're just giving the gradient, would 3 over 1 be the correct answer? No, you just say plain old what? 3, right? But when you're counting it, then you need both pieces, yeah? Rise over run. All right. And c is a constant, meaning that it is just a number part. Okay. And what does that c stand for? What does it represent in this particular form? It's the Y-Intercept. Very good. Which simply means the point at which the line crosses the y-axis. Okay? So you had excuse me. So you had some homework on those. How did they go? Pretty good. So remember that all you're doing is you're going to plot your c on the y-axis. So say you had y equals 2x plus 2. So that means on the y-axis you'd get a point at 2. Then making the m, which is always the thing in front of the x, look like a fraction. That means go where? Up 2 and right 1. So from that point, you would simply go up 2 and right 1, get another point, and make sure that the line is continuing all the way across the graph. They usually just used this part of the graph, right? But you could use the whole thing, right? Just make sure it goes continuously all the way across. Look familiar? I hope so. Good. So most of you have done quite a lot of those. But those of you haven't, just continue on with that and we'll get those done. Today what we're going to do is we're going to look at how we can use graphs to actually solve equations. Because remember, we know now that we have an equation. How do you know that thing is an equation? The equal symbol, exactly, right? And so we can use the graph of the equation to solve some equations, to solve and answer some questions, right? And we can do that by simply reading information from the graph. Sometimes it's going to be very specific information, and sometimes you're just going to be reading along the graph, reading the scale to see. For example, how many hours did it take you to eat 3 liters of ice cream or whatever, right? Okay? So that's the kind of thing that we're going to be looking at today. So we're going to look at some things in Education Perfect just to go through and talk about and see what these look like. So let's just go there. Okay? So we can use our knowledge of relationships between linear equations. What does linear mean? Yeah. Just a straight line, right? Then that's the kinds of equations that we've been working with, linear equations and linear graphs, to solve what are called linear equations. And these are called linear equations. If you want, this is an aside. This is not something you have to know right now. But they're linear because they don't have any exponents. If they don't have any exponents, then their graph is always going to make a straight line. Okay? If you have an exponent, then it starts making curves. So we're not going to have any of those. So many times, if it's easy to graph an equation, it makes it easier to answer questions from the equation. For example, let's say that all of you have gone to work in a factory, right? So you all make exactly the same amount per hour, okay? But you don't all work the same number of hours. And I need to be able to find out how much you need to make so that I can write you a check. Okay? Well, it would be easier for me to have a graph showing all the possible outcomes, and then I can just read from that graph, and I know exactly how much to pay, right? Or I could take say that Amelia worked, is that right? Yeah, thank you, worked 3.5 hours, right? And somebody else worked 2 hours, somebody else worked 1 hour. I could put that into the equation and then do the work, do the math, right? But it's a lot easier if I could just read it from a graph. And that's what we're going to look at today, is how to use those graphs to be able to answer questions. Okay? So remember that the first thing we talked about, one of the things that we talked about yesterday was something called the Y-Intercept. And we said that that's the point where the line crossed the which axis? The Y-axis. Well, if there's a Y-intercept, there's also probably an X intercept, exactly, right? And so the X intercept is simply where the line crosses the, what do you think? The x-axis, right? Seems pretty familiar, pretty easy to figure out. And for both of those points, we can always write an ordered pair. And if you think about it, remember yesterday we said that if you're on the y-axis, can I have gone right or left any if I'm stay on that y-axis? No. So that means that my x value is always going to be 0. Move right or left, none. Right? Okay? But I will have some y value, some y number that I don't know. Okay? Now, so if to stay on the y-axis, x has to be 0, what do you think has to happen to stay on the x-axis? Can you go? Yeah, you can't go up or down any, so that means that y will be 0. And we will have some value for x. Okay? So, be careful though. It's really easy to get these backwards. Think about what's happening. If it's the y-intercept, you should have a y value. Yes? If it's the x-intercept, you must have an x value. Yeah? The only thing that's weird is when we have this point. What is that point called when you have 0, 0? The origin, exactly, right? That could be an intercept. A line could go through the origin. In that case, it's the y-intercept as well as the what? X-intercept. So that's the only point on the graph where they can be the same. Okay? All right. And we're going to see how knowing those can help us out when we're solving equations. Okay? All right. So, think about the x-axis. If you're on the x-axis, you can't go up or down anywhere, so it doesn't matter where you are on that line. What does y have to be? 0. Yeah? Good. All right. Same thing on the y-axis. If you're on the y-axis, x, no matter where you are, x has to be what number? 0, because you can't go right or left and still be on that axis. So that's just showing you a visual idea of what we just did. So, many times we want to find out where x is equal to 0. Okay? For example, in this example, they're talking about graphing distance over time. I want to know how far you were when you started. Okay? Now, when you start out, how much time have you spent? 0, right? And so that's a case where we want to know when x is equal to 0. Okay? And that's pretty easy to do because if x is 0, that's the place where the line is crossing which axis? The y-axis. In other words, if x is 0, that's simply called the y-intercept, right? So we already know how to do that. And it's a really important piece of the graph. It can answer a lot of questions, and we're going to use it to answer questions in this section. Okay? So the point where on the graph where x is 0 is always that point where it's crossing the y-axis. Where would the point where y equals 0 be? That's where the line is crossing the what? The x-axis. So in this case, that would be right there. Right? So just pay attention to which one needs to be 0, and it's really easy to find. Okay? All right. So let's try this example. We're going to solve this equation for x equals 0. And it's super easy, even though this equation looks a little bad because it has the fraction in it. But since we have the graph, it's even easier. Okay? Because that line, if I want to know where x equals 0 at, what's it called? Whoops. I'm always giving away clues by writing things wrong. At the Y-intercept. Well, what is the Y-intercept for this one? -2. So the solution for this particular equation is y equals -2. If x equals what number? 0. Now, if x equaled another number, would it give you the same value? No. Right? But if at x equals 0, y is equal to -2. Really hard work here, right? Y'all are all going to make perfect scores on this coming test, aren't you? Okay, so you see the y-intercept is at -2, which means that is the answer, the solution for it, if x equals 0. You have to have both parts, though, because remember, on the Cartesian plane, can you have just one number? It's always how many? 2. An x value and a what? Y value. Excellent. Keep that in mind. Okay. So, go. Tell me what the y value, if x equals 0 here. Everybody should already have it pretty much, shouldn't you? Why? It's simply the place where simply the place where the line is crossing the y-axis, which is right there at +2. Okay? So y is equal to +2. Right? Simply a matter of reading the graph. Yes?
Is that also the constant as always?
Exactly. Because if y equals 0, remember yesterday when we actually did the math, if x equals 0, then what happens is 2/3 times 0 just goes away and gives you the constant, right? But you're not always going to have the equation. Sometimes you'll be given just the graph. And so that's why it's important to be able to read it from the graph. But yes, you're exactly right. Because remember, the y-intercept is always the constant if it's in that form. Remember, if it's solved for y. Do you think all equations are always going to be solved for y for you? Forever and ever and ever? No way. But do you think you might have a graph and some ugly equation? Yep. And you can still use the equation to go right to the number. Okay? So it's good to have as much information as possible and good to be able to understand how to read as much information as possible. Yeah? So quick, just yell out. What is the intercept here? 6. So if x is 0, y is 6. Could it get any easier? Okay? Doesn't matter if it's going the other direction. This one's going down. Nope. What's the y-intercept? 4. So if x equals 0, y is equal to 4. We happy? Okay? I think I'm doing your homework for you. I need to stop that. All right. Let's look at some where we're talking about using the X Intercept. Now, the X Intercept is the same exact idea, except it's not where X is equal to 0, it's where what? Where Y is equal to 0. Good deal. Okay? And so what we're doing is we're looking at the place where the line crosses the X-axis. Okay? So for this particular one, look at this example. We're talking about the height of land above sea level. And we might want to know where sea level is. Because sea level, if you're talking about sea level, then sea level becomes the x-axis, right? That's your horizon line. And land is either above sea level or what? Below sea level. But we want to know what the measurement is at sea level, the distance. And so to do that, all we need to find is the X-intercept. Okay? Now this one, they don't tell us the numbers, but how could we find out what that intercept is? Right? Okay, so we're going to find that X-intercept, which is the place where it crosses the line, which is right there. But I don't have any numbers, so I can't just read it. So I'm lost, right? I don't know how to do it. What do I do? Well, can't you just count? Don't forget how to count. Okay? Now, I don't know the scale, but I can say that it is 1, 2, 3, 4, 5, 6. And I guess we're talking meters here. Okay? I'm assuming that each one of those is 1 unit. And you get to do that as long as they don't put a scale. Now, what if they said 10, 20, whatever, right? Then you need to use their numbers. But if there is no scale, you get to assume that each one is 1 unit. Okay? Yes?
Wouldn't the whole of the x-axis be sea level though?
Yes, everywhere across here would be at sea level, but they're just talking about finding that height above sea level at that point. For some reason. I have no idea why. You bet. The entire x-axis would be sea level, but for some reason they just want it at that particular point. Maybe it'll come through with some more information about this question in a minute. Let's see. Okay? So, the point where the graph is, where y equals 0 is always the point where it crosses the what axis? X-axis. Excellent. Okay? So, let's solve this one. Do I have to worry about the graph? Nope. I'm sorry, the equation? Nope, because I have the graph. But this time we're solving where y equals 0. So what number would that be?
6.
Positive 6, right? Just the X intercept is what I'm looking for in this case. And again, I know that because it says y equals 0, which is always the X intercept. Okay? So be careful, read carefully, because they're going to bounce back and forth and ask you different questions. They're very easy, but they're going to bounce back and forth and ask you different ones. Looks good? Let's see. All right? And they just walk you through that. Okay. We can also be able to look at other pieces of a graph and answer questions. So if you look at this graph, we're talking about how fast seaweed grows in this particular example. The y-axis is labeled the height in centimeters, right? The x-axis is the what? Time in days, okay? And then we have our graph. Well, so I can ask you any question, and you should be about how many days, and you should be able to tell me how high that plant has grown. Make sense? Okay? And so that's what we can tell here. So she's growing her plant in an underwater garden. So obviously it started out. How tall is the kelp plant after 6 days? Well, days is on your x-axis. So all I have to do is go over 6. 1, 2, 3, 4, 5, 6. And then just follow that line up until it hits the blue line. Yeah? And that's at what height? 8 centimeters. Thank you very much. We always have to have units, right? There you go. Rocket science. You really happy with it? Sometimes math is easy. Okay? But here's the caveat. When it looks easy, how much do you practice it? Not at all. Then what happens later when you need to use it? Yeah, you forget, all right? So even if it's easy, still study it and make sure that you understand exactly what's going on and that you practice these. And don't just go through them as quickly as you possibly can just to get it over with. Really try to understand what it is you're working on, okay? Because I cannot tell you how many times I've seen students say, oh, that's so easy, right? And you can also remember when you're working on these, you can use those drawing tools to help you draw these lines right on the graph. Because I don't expect you to rewrite all of these graphs, to redraw all of these graphs on paper. This is one of those instances when it's fine to do the work, show your work on Education Perfect, but make sure that you are using the lines. Okay? All right. So, we can also do it when we're just given an equation and we want to find a specific number. So this one, we want to find the solution to this equation when y is equal to 6. So all I have to do is remember that y equals 6 on the y-axis, where? Up 6, right? So there's the line where y equals 6. And here's the point at which it hits the graph at that particular thing. So let's just go down and find out what that value is, and what is it? So x equals what? 5. Okay? Exactly the same thing we did when we were looking at the Cartesian plane, and we just counted the points, right? So all you need to do is just find out where that point is on the graph. Okay? So if x equals 4, again, x equals 4 here. So go down until you hit the line and go over, and that means that y is equal to what? -3. So it's exactly the same exercise that we used when we were finding the coordinates for an ordered pair, except this time it's on a whole line. Looks good? Y'all are going to be so ready for that test next week then, right? Nobody reacted to that at all. Okay. Good. I'm glad. Okay. Let's look at this topic. It says we just learned to solve them by reading off points. We also want to solve an equation. We can solve things graphically. Okay. So just think of the graph of a line. So all I did was take the information, the slope and the y-intercept, graph the line, and then locate any point on the line, right? To solve an equation. Kind of a summary of that. And they actually give us a summary. Let's see what that is. All right, so how happy are you about being able to solve for a given number if you have the graph? Okay? Good deal. I like it when things are easy.